Hey guys, Raz here, just filming from San Francisco, you know what I mean? Um, Get that beautiful view back there. Um, Today we're going to be looking at differential equations for year two of the A level. So I've got a question here that I'm going to use as an example, but really just going to go straight into it. So here, a timing device, in the timing device, sound falls through a small hole to form a conical heap. As the cone forms, the height h remains equal to the base radius of the heat. The volume of the sound off is v is c centimeter cubed. Explain why. Explain why v equals a third pi h cubed. So we know that the volume of a cone is equal to a third pi r squared h. It tells us as the cone forms, a height remains equal to the base radius. So we let h equal, or r equal h. Therefore, we get a third pi r, h squared times h, which equals third pi h cubed as required in this question. Yeah? So we're probably going to need that in part B. I didn't really need to answer that for this video, but I did because it was there and prepared quite right. So it made no sense not to do it. So now let's get into the bulk of this, and we're just going to deal with these sort of exam questions. So we're told the sand falls through the hole at a rate of 3 centimeters cubed per minute. Find the rate at which the height of the heap is increasing and the instant when h is 2. By all means, if you think you can answer this question, pause video and give it a go. Welcome back. So my tip here would be to write a chain rule. Yes, we just need to find 3 letters. Yeah. So we have 3 variables. So we know we have a v and an h because we've got that formula given to us. So dv by dh equals, and then we write the chain rule like that. But what is the missing letter? Sound falls through the hole at a rate. So we've got centimeters cubed per minute. So time is clearly the missing variable. Well, we want to find the rate at which the height is increasing. So dt by dh, or dh by dt is our unknown. So the other 2 must be in the question. Yeah? Sand falls through the hole at a rate of 3 centimeter cubed per minute. So that is dv by dh. We can tell, sorry, dv by dt, we can tell from the units. We have volume and time. So dv by dt is 3. Find the rate at which the height of the heap is increasing at the instant when h is 2. The instant when h is 2. So we know that v is equal to a third pi h cubed. So dv by dh must be a third times 3 pi h squared. We're told h equals 2. So that is 2 squared pi. So dv by dh is 4 pi. So I know 4 pi equals 3 times dt by dh. So dt by dh must be 4 pi over 3. And because we want dh by dt, we take the reciprocal of that. Centimeters per minute, because height is in centimeters and the time is minutes. There you go. So I'm going to do that question a different way. maybe when you read the question, you want to write the unknown first. So you read the question, it says, find the rate at which the height is increasing. So rate is a hint that we're dealing with time and height is h. So maybe you write your chain rule like this. And then you look for the third letter, and we've got a giant V equals a third pi h cubed. We're given centimetre cubed. So really, you should realise that third letter is volume. So once you've done that, we need to write down what we have. V equals a third pi h cubed. Differentiate that. We know h is 2, so that gives us the 4 pi. But we have dh by dv. So we want the reciprocal of that. So we know that is 1 over 4 pi. The sound falls through at a rate of 3 centimetres cubed. That is dv by dt, so that is 3. So we can see if we went this way, we'd also get the same answer. Yeah? All right, we've got 2 more examples. Let's give them a go. So find dA by dr in terms of our, at a time t, a circular puddle has an area. So A equals pi r squared. So when we differentiate A with respect to r, we get dA by dr, which is 2 pi r. Job done. That's part A done. The radius is increasing at a rate of 3 centimeters per minute. So that means dr by dt equals 3. Find the rate at which the area is increasing when r is 50. So we want to find dA by dt. The rate at which the area is increasing means area with respect to t differentiated because it's the rate of change. So dA by dt, so I'm going to write the A there, the t here, and then the third letter in the gaps, which we know is r. I know dr by dt is 3 from this work we've done on the side. I'm just reading the question. And dA by dr is 2 pi r. At the instant when the radius is 50, that equals 100 pi. So dA by dr is 100 pi. So the rate of change of area with respect to time must be 3 times 100 pi, which is 300 pi centimeters squared per minute. Make sense? All right, one more. One more and we bounce out of here. All right, pause the video, give it a go. Welcome back. So all I'm looking for is 3 letters to start. Volume of a spherical balloon is that 25 centimeter cube per second, yeah? So that is dV by dt. So I'm going to write dV by dt equals, and write that in. Now I'm just looking for my third letter. Find the rate at which the radius is decreasing at an instant when the radius of the balloon is 2. Well, that's got BR then, doesn't it? So find the rate at which the radius is decreasing. So dr by dt is the unknown. dv by dr, we need to figure out, and dv by dt is 25. The volume of a spherical balloon is decreasing at a rate of 25 centimeter cube per second. So that's 25. Because it's find the rate at which the radius is decreasing, I don't need to put minus sign in. I just have to put that in my answer with the word decreasing. Yeah? You can either say it's increasing at negative rate, or we can leave it positive and say it's decreasing it at this rate. So the volume of a sphere is 4/3 pi r cubed. So dv by dr is 4/3 times 3 is 4 pi r squared. We're told an instant when the radius is 2. So that gives us 4 times 4 pi. So dv by dr is 16 pi. So dr by dt equals 25 divided by 16 pi. Find the rate at which the radius is decreasing. So centimeters per second. So because I haven't put a statement in, let's put minus. So I can then say the balloon is decreasing at a rate of whatever that is, 25 divided by 16 pi, 0.497 centimeters per second. Yeah, I hope that video has been clear. I've just obviously did it with 3 worked examples. Yeah, see you again soon.